This is Precalculus, section 5.4, day 2 notes, more trigonometric graphs. Today we are going to learn how to graph cosecant and secant. Good news is, I think that of the 6 functions, next to sine and cosine, cosecant and secant are the easiest to graph, and that's because they are the reciprocals of cosine and sine. Okay? So first of all, we're going to graph the parent graph of cosecant. And we're going to start by sketching in the graph of sine first. So the normal graph of y equals sine t has a period from 0 to 2 pi, right? And it has an amplitude of 1. So I'm just going to sketch in my picture frame first. Here would be my picture frame for the parent graph of y equals sine t. And then the graph itself, the parent graph, starts at 0, is at 0 in the middle, is at 0 at the end, is at its maximum height in the center, and is at the bottom in the center, and here's my sine curve. Okay? So that's the parent graph of y equals sine x. Now we know that cosecant is the reciprocal of sine. So first I'm going to start by filling in the table. If you want to know how to get these values, remember cosecant is the reciprocal of sine. So if you do 1 over sine of negative pi on your calculator, you will get undefined, right? Because you're going to have 0 on the bottom. 1 over sine of negative 3 pi over 4, that gives you negative 1.4. So on and so forth. These are all just the reciprocal. So it's 1 over sine of these values. So this one is negative 1, negative 1.4, undefined, positive 1.4, positive 1, positive 1.4, undefined, negative 1.4, negative 1, negative 1.4, undefined, positive 1.4, positive 1, so on and so forth. Okay, so if I start sketching those values, first I need some labeling on my x-axis here. So this is 0 here, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Okay, so I'm just going to worry about sketching here in my 1 period section. Okay, so if I start plotting these points, at 0, my function, my secant is undefined, so I'm going to have an asymptote there. Okay, so there's an asymptote right here. And then at pi, I've got an asymptote. It's undefined. And at 2 pi, I've got an asymptote. It's undefined. Okay, so now I'm going to plot the other points that actually have values. At pi over 4, remember this is 1 and this is negative 1. At pi over 4, I'm at about 1.4, so right there. At pi over 2, I'm at 1. At 3 pi over 4, I'm back at 1.4. Pi, I'm undefined. 5 pi over 4, I'm at negative 1.4. 3 pi over 2, I'm at negative 1. 7 pi over 4, I'm at negative 1.4. And then at 2 pi, I'm undefined. And then this just keeps repeating. Well, if I connect these, and remember the graph is going to approach the asymptote on both sides, basically, you can see that it's just like the reciprocal of the sine function. It's just the sine function flipped over. So it looks like 2 parabolas here that are trapped between the asymptotes. So this right here represents 1 period of y equals cosecant t. Our x values go from 0 to 2 pi, and sorry, those should really be round brackets because we have asymptotes. And our y values go from negative infinity to positive infinity. Okay, now let's take a look at the parent graph of secant t. And we're going to start again by sketching in the graph of y equals cosine t first so that you can see that relationship between these two reciprocals. So if I look at my picture frame for cosine t, positive 1 and negative 1 on my y-axis, my picture frame goes from 0 to 2 pi. But cosine, remember, is the cup. So our cosine graph starts out at the maximum, ends at the maximum, and is at the minimum in the center, and then crosses the x-axis exactly halfway between. But remember, we are a cup shape, not a V shape. So our graph looks like that. That's our y equals cosine t parent graph. Our table's already filled in for us here. So we can go ahead and we can do some graphing, but the first thing I'm going to do, I'm going to label my x-axis, and then I'm going to put my asymptotes in. So here's 0, and then we've got pi over 4, pi over 2, 3 pi over 4 pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. All right, our asymptotes. We have an asymptote at, let's see here, pi over 2. Undefined, right? That's where I'm looking at. I'm looking at where things are undefined. We have an asymptote at 3 pi over 2. We would have another asymptote at 5 pi over 2. And back here, we would have an asymptote at negative pi over 2. Right here. Okay, so we're drawing in a few extra here. Okay, so now we can go ahead and plot the points in our table. At, let's see, 0, we are at 1. At pi over 4, we are at 1.4, very familiar points. Then we're undefined. At 3 pi over 4, we are at negative 1.4. At pi, we're at negative 1. Or sorry, yeah, negative 1. That should say negative 1 right there. At 5 pi over 4, we are at negative 1.4. And then we have an asymptote, we're undefined. At 7 pi over 4, we're at positive 1.4. And at 2 pi, we are at 1. So if we go ahead and sketch this in, it's going to approach our asymptote there. It's going to approach our asymptote here, and approach our asymptote here, and approach our asymptote here. Okay? So technically, that's what one period right here of y equals secant looks like. From here to here. Okay. So we've got, instead of having two parabolas, basically now we've got one parabola in the middle and kind of two half parabolas on the side. This is one period of y equals secant t. And again, our x values for this graph go from 0 to 2 pi. And our y values go from negative infinity to positive. Of course, we can transform cosecant and secant just like we can transform any of our trig function graphs. The same rules apply. A k value affects our period, so that's either going to horizontally stretch or shrink our picture frame window. Our b values are phase shift. That's going to move the graph left or right. An a value is going to change our amplitude. So that's either going to vertically stretch or shrink and or reflect if it's negative, our graph about the x-axis. But just so you know, for whatever reason, they don't call it amplitude for secant and cosecant. They just call it the A value. And I guess the reason they don't call it the amplitude is because it doesn't represent the highest point on the graph like it does for sine and cosine. And then finally, our H value moves the graph either up or down. So the period of our parent graph of secant and cosecant functions is the same as the period for sine and cosine. It's going to be 2 pi. And if we have a k value, our new period, just like before, is going to change to 2 pi divided by k. So for our next example, we're going to graph y equals 2 times cosecant of x. So first, let's talk about what we have. We have an a value of 2, which is going to be a vertical stretch by 2. We don't have a k value, so our period isn't changing here. Our period is still going to be 2 pi. Now there's a little note here on the side that says, hint, make the changes to y equals sine of x first. And that's great advice. So the first thing that I'm going to do is I'm going to sketch in what my picture frame would look like if I were graphing 2 sine of x instead of 2 cosecant x. Okay, so if I were graphing that, my picture frame, this is 1 and 2, this is -1 and -2, so it would go from -2 to +2 on the y-axis and from 0 to 2 pi on the x-axis. So this would be my picture frame, and my graph of sine, remember, begins at 0, is at 0 in the middle, ends at 0, is at its max here, and is at its min here. Okay, so that represents y equals 2 sine of x. Now I know I want to make the reciprocal of that. I'm going to start by sketching in my asymptotes. My asymptotes are going to be where sine is at 0. So at the start and the center and at the end of my period. And then I just have to graph those reciprocal points. But basically, you don't have to make a table for this. You know what the shape looks like. The points are just stretched out, right? So it's going to be here and here, and then it's going to be up here and here. So it's going to look like that. Sorry, I put those a little bit too high. Those should be right there. And then that's going to be right there, right there. There we go. So we just graphed y equals 2 cosecant of x. For our last example, we're going to graph secant of x minus pi over 2. Again, our period is still 2 pi. We don't have a k value, but we do have a phase shift. Positive pi over 2 means that we are going to be shifting everything pi over 2 to the right. Before I do anything else, I'm going to do a little labeling on my x-axis. So this is 0, this is pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 6 pi over 4 is 3 pi over 2, 7 pi over 4, 2 pi, and then 9 pi over 4, and 10 pi over 4 is going to be 5 pi over 2. Okay, so my picture frame is going to be shifting pi over 2 to the right. My amplitude's not changing, so I'm at -1 here and +1 here. It's just that my picture frame is now going to be at pi over 2 to 5 pi over 2 instead of 0 to 2 pi. That's my only change here for my y equals cosine of x minus pi over 2. Okay, so I sketched in my picture frame. I know what my cosine looks like. It's the cup. So it's at the top, it's at the bottom, it's at the top, it crosses in the center, and it looks like that. Okay? So now my asymptotes are going to be where cosecant, or sorry, my asymptotes are going to be where cosine is at 0. So I'm going to have an asymptote